Good day. Thanks for having me. And yes, we're going to talk about secondary operations. That's, of course, a relatively fairly generic term. So I could be telling pretty much anything I want. But to set the stage today, we're going to do a little magic trick. And that's to basically tell you it's okay that the following things that I'm going to show you are applicable to your situation or your company's situation, right? I bet I know what the most powerful user is in your platform. We're not here to name and shame, so when you answer the question for yourself, use your inner voice, but try and work out what your answer would be. I'm gonna give you a hint. I'm 99% sure it's not root unless you're in a highly controlled situation. Perhaps some bankers in the room, you're excluded from this experiment today. Hey, I'm also 99% confident it's your own SSH key. Hey, why? Because it's never been rotated. Since you joined the company, again, unless you're in a highly controlled situation, your SSH key, your credentials, they've probably never been rotated because it's something we've been ignoring. It's not pretty. It's the thing that you generated on day one when you started your company or day zero when we started the company. And it had no unique selling proposition to actually set up something correctly. And now we're X years in, 4 years in, 5 years in, and the key is still there. Not only is that key still there, the database password or credentials for your main database, for your main product, also have never been rotated. I'm fairly sure. Backup scripts, all those kind of stuff. We set them up once, we forgot about it, unless we got an ISO certification going on, then we, made a ticket. Never made it onto the Scrum planning, or came up, even the PO knows this is the bottom of the Scrum list of the tickets that never going to make it. So we might have an issue with these credentials. And so today we're going to discuss some of the basic tasks platform teams, operations teams do every day, while actually trying to get rid of these passwords that have never, or credentials that have never been rotated. Right, who am I? I'm Bram Vogelaar. I went to university, become a molecular biologist, or more specifically to work in pharma research. Actually lived quite a while here in the UK. I worked at GSK in Stevenage. I worked at Oxford University. And that's actually where I worked out that I'm incredibly lazy. The lazy that actually is useful in job interviews. I do not like to repeat myself. I am terribly bad at these manual jobs. We used to generate 300,000 data points a week and no real means of analyzing them. So I learned to program because I worked out that if I can ask a computer to do the lazy stuff, so I can actually apply myself to do the things that I went to university for. Well, turns out in an academic world, when you're the developer guy, right, I started programming, started doing statistics, you're also the operations guy. Same rules apply, lots of manual stuff, which I hated, so I tried to, and that's how I got into initially Puppet and now eventually Terraform and the amazing tools that HashiCorp has generated for us. I'm really into the HashiCorp ecosystem, so hopefully the Amsterdam hug is going to be start up again, and I'm currently an ambassador for the program. So we've set the stage. We have these passwords that have never been rotated, and we use every day to do our job in the platform team. So today we're going to describe some of the tasks that let's call it HashiDays Inc. or HashiDays PLC does on a regular basis, but uses credentials that should not be there or should no longer be there, should have been rotated at some point during this exercise. And I'm going to do that by showing some of the bits of Vault and later on Foundry that you may not have used before. So I'm going to show you some of the secrets engines on top of the KV store that everybody basically, when you go to the, let's learn Vault, and then it's KV secrets, and we're done with it. And as discussed this morning, that's very good. Move everything into Vault so you at least know what secrets you have. But now we're going to try and apply this to our daily use where perhaps a KV is not what you need. So first of all, let's start rotate the secrets right now, because one of our colleagues, or in case me, we've been forced to leave the company in one way or shape. But this person had access to all the KV stores, and all these secrets might still be in play. The other reason being is, let's take GitHub Actions as an example. So let's do some CI/CD, and GitHub Actions being one of those things that I think Armon also pointed out this morning. It has its own secrets and storage built in. Some of these things don't automatically rotate that well. Right? Most CI/CD solutions will have the problems. Jenkins had the same problem. We stick Jenkins, more specifically, GitHub Actions is a write-only system. So some of these secrets, you might not even know what the actual secret is anymore. It's just GitHub Actions secret. So if we ever lose this, or the thing underpinning the credential, right? Remember, we set this up on day 1, day 2, so probably this is a personal token of someone that started the company. So we need to rotate this very quickly. I'm showing on screen now for those not experienced or that haven't experienced GitHub Actions before, it's a YAML-based system. You stick it in your repo, and you describe the steps necessary to do your CI. In this case, I'm showing an example of that uses a plugin, a provider based actually that uses the Vault action, nicely provided by HashiCorp itself. It has a couple of issues. Right? We need to point it to our Vault cluster. We need to give it some credentials. In this case, I'm actually showing an app role, because this is how old the code is. But you're probably better off using a JWT or JOT for friends to do it. But here, there's a couple of lines where it basically says $secrets and then read something from GitHub. So another issue that we have as a platform team, this is something we need to keep updating. If someone adds a new repo, this is something we need to add to the repo. Or in scary worlds, you can actually set it globally for your GitHub org, and then it counts for everybody. So we as a platform team actually become a bottleneck on doing these tasks. So what we actually would like to do is solve these two issues at the same time. We don't want two systems that have a source of truth. We only want Vault to be the source of truth, and we want something that actually rotates it for us, right? We're lazy, let's have this system that we already pay for, that we've already running, do this rotating for us. If you permit me a little bit of an explanation. First, on the GitHub side, we need to create an application. Unfortunately, you cannot Terraform this, so we're going to show you some screenshots. Right in your developer settings, you add a GitHub app. This is something someone needs to do. You don't have to do this for every repo. And then you install it to a repo. So you get a nice little modal, and this is actually a bit where we can start doing Terraform. So that's the example we're going to show next. Right? We read from a GitHub repository, in my case called ATC. And what I want to do is I set up this app, I install it on this repository with an installation ID, which isn't always easy to find. But that's how we link the two. Right? We have an application now installed on our repo then since Vault 1.6, which is something I'm super excited about abusing. Before, it was very hard to actually get that secret into GitHub Actions. That's why nobody did it using Terraform. Because as some of you know, and I'm going to enlighten the other half of the room, Terraform state is amazing. Terraform state is also unencrypted. So if yes, you can Terraform a GitHub secret, the actual values will be in your Terraform state. So if you do have done this, be very, very careful with the access to the S3 bucket that is underlying this state. Right? So now, what we can actually do, we can still Terraform it since 1.16, but we need a couple steps. Right? We actually write into KV. We set up a GitHub app. We link the app ID we've seen in the previous slide. And we provide the primary key. This is something I haven't shown in the screenshots, but when you create the app, there's a place where you can create a private key, and this is the magic that is used to actually link the two things. This is how it becomes secure or well known to each other. So stick that somewhere nice in Vault, for instance. And then we actually tell Vault, like, we need a sync location. We tell it the installation ID, what repo we need to connect to, and the app name. So now not only do we have an app that knows the GitHub repo, we actually know how the two are familiar with each other, and that we're going to sync some things. Then the last thing is actually we set up a new KV. We mount it at a place that is well known, or we give it to a team. This is something we also could have terraformed. So probably if you deal with something like Waypoint, we could have made a nice Waypoint module that caused us to set this up for everybody. And then now what the next step is, we basically say so the app team themselves can actually, this is app team side. So we could have wrapped this in a module and said, right, I want to sync the specific secret out of my Vault namespace into GitHub. And of course, the beauty there is it's also sync. So if we ever change this thing if we change this value in Vault, for instance, because we're required to rotate them, now that we know the secret is here, we can rotate them, and then Vault actually syncs them automatically upon change. So there's also no lag in, not even lag. Most of these SEV 231 I've seen is, someone left the company, so the secret, GitHub Actions secret no longer exists, or someone tried to rotate and then worked out that it was used in a location that we weren't used to. So by using this, actually, when you change Vault, it changes GitHub or any other sync location that you've set it up for. So again, thank you, technology. I can sleep well, and I can now actually dare to change these secrets that have been around for years and years. Right. Let's move on to observability. We've been used to monitoring. Monitoring was fine. The metrics that we exposed, CPU, RAM, nobody cared. If someone leaked this inside your company, now that we're doing observability, so that's actually a layer on top of monitoring where it says your application should send out enough signals that from the signals you can work out if the application is working or not. So actually what you're layering on top of them is business metrics or business signals, right? How many sales are we doing? How many people are online right now? How many people are abandoning their shopping carts? Those kind of things. And that's not something you want to have available open on your network, right? We all have IDP on top of our Grafana, so that's all fine. But what nobody tells you is that the Nomad exporters are all basically plain text. So if I work out what nodes they're on and what standard port they're on, I can get to any metrics without ever having to go to Grafana. So that's actually a risk. So let's investigate the PKI engine. Right? If you for the people writing along at home, what it should have said, securing Prometheus itself, right? There's a configuration flag that you can flip. It's called required and verified client cert. So now at this point, I actually need to present a valid certificate to Prometheus. Vault actually provides a PKI provider. For the sake of the time today, we're going to skip actually how we're going to create the PKI and stuff. I'm just actually going to show how we're going to rotate them. So securing actually the node exporters is actually you add a section where you now say your scheme is HTTPS and here are my certificates. Again, certificates are something that are potentially long-lived. We might be scared of rotating. So even if you have set it up properly, this is something, this cert is probably everywhere. If you've been a good person, every node might have a node-specific cert, but most of the time with central services, was too difficult to work out. We blitz the central certificate. So everybody has a certificate that's never been rotated. So we're back to square one. Yes, it's HTTPS. Yes, the ISO auditor is probably happy. Because we actually haven't told him that everybody has a certificate. So let's introduce a section of Vault that other people. Well, I was pleasantly surprised when someone told me Vault can actually run in an agent mode. So in this case, we're gonna stick Vault agent on every node, and it's gonna do this automatic rotation for us. Actually, giving an app role, again, as I mentioned before, app roles is probably not what you want to use. You want to use JWT, so we'll skip quickly over it. And this is a section that is interesting. You actually, in Vault agent, the config, you can template out certain instructions. In this case, I'm actually templating out the config file for, not necessarily a config, I actually template out how to obtain these secrets that have been rotated and where to place them on the system. So as soon as Vault agent works out that in Vault proper or the central instance of your cluster, the certificate has been rotated, because you actually can tell them to auto-rotate. We pull them in, stick them on the system, and actually we restart our node exporter. So in our case, it was every 5 minutes. So now I didn't really know how to express this better than Prometheus itself. So before it was all fine, and now the certificates have been rotated, so I can no longer access the thing. So we can now actually honestly promise the ISO auditor that we're all good. Next step is, right, we are a platform team, we provide services. Some of our colleagues might not be as tech savvy as we are, or so we need to provide some services to them. In this case, Ben, the BI guy, he's amazing with Excel sheets. He can basically make them tell the customers inner secrets, but he wants some database access to get a dump and do his analysis. In normal cases, this would be, write a ticket, we would do the dump, or give him access. He would do his thing. He would tell us he would done another ticket about cleaning up his credentials. Luckily, Vault actually provides one of these engines where you can do just-in-time or short-lived dynamic credentials. In this case, we enable the database engine, and we tell it how to connect to our Postgres server. And in this case, this would be the only place where the secret now is residing. And then we tell Vault how to actually create a read-only user. We write it into Vault with the add read-only.sql. That's the thing that I should have pointed out. That's the easy way. That's how you can write an entire file into your KV store instead of having to work out again in Bash how you do multiple line variables. It's very easy. Add file, boom, written out. And now we can basically give this to Ben, the BI guy, right? Vault, You have access to vault, read-only credentials, boom, password, and a lease duration of an hour, right? This thing expires automatically after an hour, no more tickets. He's fully self-sufficient. There's similar ways of doing this for SSH connections. For the sake of time, I'm also skipping them because we're circling back in a minute. Also, this works very well for your backup scripts, right? The other place, the most powerful place in your system, right? Where the backups are living or the backups are created. Like, I will never attack your primary database directly. I'll try and attack your backups because they're basically most of the time plain text. So we've done dynamic secrets, Ben the BI guy, and Sue in finance. They can all access the data that they should be doing. So this is probably the end of the talk, unless this is one of these messages that show up pretty much after that. Can you just stick it on the FTP server anyway? Right. True story. That's when the point of this was a message into a group Slack thing, and this is when the keyboard started flying. Right? We spent lots of time setting up Vault. We spent lots of time setting up dynamic secrets. And wait, SFTP server. Like, we weren't even aware you had one of those. What's the data retention on those things? Better not. We'll just ignore that bit for a minute, because this is the reason. Conway's law, or in my dictionary, Conway's OU group. Right? We gave them Postgres access. However, Ben the BI guy had no way of getting to this Postgres database. Right? He's in a different business unit, and the powers that be have decided that the business unit Ben is in has no access to our infrastructure. For good reasons, where we saw this morning, right? We probably only created a flat network, so if we give Ben access to the jump host, right, he'll have access to everywhere. Of course, we trust Ben that he's not to destruct anything, but we can never be sure, because if Ben's password is still welcome123 exclamation mark, if he gets hacked, we get hacked, they have access to the entire network. So boundary is the solution. And in my world, I always introduce boundary as following. Boundary is to your network as Consul service mesh is to service mesh. Didn't work, right? But it's a way we stick boundary on the outside. We basically abstract away most of the network while still giving people access to the bits that they need access to. So I loved when HashiCorp actually came out with boundary, and I tried to understand what they were doing. So boundary can now also, because we can model our entire infrastructure, we can also start using boundary as a source of truth. This is a screenshot of the UI. Luckily, I can also model them quite lazy. We write it out in Terraform code. If this ever craps out, we can just rehydrate from our Terraform code. Boundary uses the notion of scope. So top notion is org, or in this case, our HashiCorp Inc. of PLC, and it has scopes underneath. In our case, for Ben the BI guy, they'll have a BI scope. Now we can actually still give Ben access to his database by basically having a boundary target that we point at internally we point the worker at the IP address inside of our network, and we'll tell boundary it's of type TCP. And on your system, on Ben's system, it's going to be mounted on port 5432. And in that case, he can just connect type Postgres to this target that has been produced. And now Ben has SQL access on his node, while we still protect the sanctity of our network. Right, so the last one is lifecycle management. Right? Can you update that web service we were talking about in the stand-up this morning? So let's model that one. We have a catalog of web servers. This case, it's all static for the example, but we can make it dynamic. Boundary can actually read out AWS or other cloud providers the nodes that have been produced, so it can actually create a dynamic catalog as well. In this case, our static catalog has a static node called our web server. Boom, all done. Right? This way, we have in Boundary, we have the same power as you have in your CMDB. And then we can actually tell Boundary, use some credentials that we've predefined in Vault. Linked it to. So now we can actually give people access to SSH access to all these servers without actually having to have this SSH key that's never rotated, or in worst case, we have the platform team SSH key that everybody and his dog that ever worked at our company has access to. So we can let Vault do these rotations for us. And this also lets us create, for instance, very nice Ansible transport of Ansible inventories. Right, before, we had to point them at an IP address, at a port. We needed to provide the SSH key and all kinds of palaver that sort of bled information from the platform team to the teams. Or, it bled information to people that shouldn't need it, just for the sake of getting to this system. So if you use Boundary, you connect to it. Your Ansible inventory becomes very, very simple. And the last one is a subject that I think Kerem did in HashiCorp Europe for a while ago. Boundary can now also be used. Right? We have an inventory. We have ACL set up. That's something we sort of scooted over today. But we have ACLs. We have an API. Boundary has an API. So now we can also do break glass as code. Right? We have an incident. Our tool sends a message to, or our pager duty or whatever. Now sends a message to Boundary. Team X now has access to their production servers for the next hour or however long the incident is running. And as soon as the incident is over, we send the message to Boundary again, and the system gets locked down again. So if you're interested in this particular story, I send the link at the bottom to the blog post that introduces Kerem's story. Because he literally filled the entire half hour explaining this, so I'll cop out and I'll give you the link. And that brings us to the end of my talk. So thanks for having me. Thanks for listening.